Hello again, dear students. Today I'm going to talk about an important thing in the new chapter. Chapter 4 is talking about the application of derivative. The application of derivative means that to find the derivative or using the derivative for many purposes. One of them is the extrema value of function. When we say extrema, we mean by maximum and minimum together. So the extrema value is one of the important things that will help us also for sketching the graph. Okay, the graph. So it's also important. So that's why we are going to use first derivative exactly for finding many things and finding the critical point or inflection point and many concepts that they are help us for sketching the graph. In here we have what we have. If you have first definition in this chapter, we have many concepts or many definition and theorems because we are going to use it in the 4.3 4.4. That's why we are starting by defining these concepts. We have a maximum and minimum, or absolute maximum and minimum, because we have a two type of extrema. We have a local and absolute. So absolute and local. The difference between them, they have the same definition, but the difference is what here we are means there is no interval. Here we have interval or intervals. Okay, so that's the difference between them. So the definition are the same. For example, we have absolute maximum, and also the function has got domain D. In this case, we say that f of x, there's a point C, that the f of x is less than to this C. So the C will be the maximum of all these value that we have in the domain. That's why we have a maximum value. For the minimum value, we say in the D we say our domain. If at C we have minimum, such that this C is less than of for all the value of the our functions. Now I'm going to clarify this this definition by what? By the function. For example, if you have between sine, if you have a cosine, okay, from 0 to pi over 2, we have a cosine. So I'm going to say that find the maximum and max and mean, or extrema. So how we find this function? We see that the cosine is between 0 and 1. So in the interval, on the interval 0 and pi over 2, the value of y is equal to f of x is equal to cosine of x has got a value. The maximum value, we say there exists C, or there's a C in the domain of this function, which we have a 0 pi over 2 because we are restricted, we cut the domain. So the C between these values, such that as we follow the definition, he say that f of x is less than or equal to f of c. So which value of this function, which value we can find in this domain, that all the other values are less than or equal to this value. Look at here. If we have 0 at x is equal to 0, the value f of x, or cosine of x, will be what? If I put 0 here, I will get cosine 0 is equal to 1. So 1, when I found the c is equal to 0 and belongs to the domain, at this point the function has got the maximum value. At this point in the domain, the function f of x has got the maximum value. That's, we say we find the c. This is about the definition, about how to understand this definition. Okay, dear? So the c, for all x in the domain, you will find the c in the domain. Okay, at c. That's the point. How about the other part of the function. You see about the minimum. You see there exists C in the domain such that f of C, okay, will be less than or equal, okay, of the all the other value of the function, for of the all other values of the function. What do you mean by this one? Now I found the pi over 2 in my domain. It's not depend every time. It shouldn't be in the middle or in the endpoints, such that you know the domain is 0 pi over 2. F of pi over 2 is less than over whole value of function, because if pi over 2 is equal to 0, so here you can see the function f of means that cosine of pi over 2 is equal to 0, so that's why I put 0 here. So it's less than of the whole the value. That's why there exists pi over 2 in the domain such that f of pi over 2 is equal to cosine pi over 2 is equal to 0, and this value is less than for whole the value of the function, so our C is pi over 2. That's all. You can see also in the function there is no value greater than 0 here, and no 1 here, and no value less than 0 here. The same thing is true for the other functions. Have the sign between pi over 2 and minus pi over 2. Okay, so how about if I change this value, the same function f of x, if I change it between minus pi over 2 and pi over 2, you can see the function. You can sketch the graph. You know how to do it. Here's minus pi over 2, here's pi over 2. Now tell me about the maximum and minimum. The max at, don't forget, C is equal to 0, we will get 1 here, the same answer. So our maximum will be 0, and f of 0 will be 1, because you have a cosine, you know, we have a cosine of function. And the minimum will be both minimum at C1 is equal to pi over 2, f of pi over 2 will be 0, and C2, look, we have a 2 minimum point is equal to minus pi over 2. Why? Because also in the minus pi over 2 I am going to get also, we will get them another minimum point, 0. So here's the definition of C. How to find the C? With C make our function to be max, or C will make our function to be minimum point. Please try to review this one. Here's the function. Also try to use the sign. Find the sign. Okay, find the sign of function. And there's a definition and the details in here. Okay, so for the next, we have an example in page 2. We have an example, page 2. Say that if f of x is equal to x squared, but with the different cases. Example 1, A, let me see example 1. Okay, in 4.1 section. Part A, he say what? Y is equal to x squared, but in the whole domain. As you know, our function will be like that, the graph. So in that case, where's the minimum and where's the absolute minimum? Where's the absolute maximum? So you know, there is no value less than 0. That's why I say at c equal to 0 or x equal to 0, then f of x, which x squared will be 0. Okay, but how about the maximum? Is equal to what? So we have a minimum. At 0 I get 0, so 0 0 will be our value of the minimum point. When I say minimum point, means that I have an ordered pair. I have a pair. like x and y. This is c, this is f of c. Okay, dear? That's why I put the value. If I'm going to write the minimum point for here, I'm going to write pi over 2 and 0, or if it's a max. If I'm going to if I'm going to write maximum point, I'm going to write 0 and 1. For what? For which function? Cosine. Oh, sure, that I gave you the detail before you taught. Okay, dear. So do not forget about the c is a something. So our x finding the value, and f of c is the other things, and both of them will give me points. Now, how about maximum point? You see there is no maximum point because there is no bounded. This is going just to up. There is no c. We cannot see is equal to this one, and the value is very, very important, very, very large. For example, if you say 4, so put the 4 is equal to 16, but more than 4 we have something else. For example, you say 4, so we have a 16. So 4 and 16 is not our maximum point, because if I put 5, I'm going to get 25 and go on. So that's why there is no limit, there is no bounded. So there is no bound of the upper, there is no maximum, just we have a minimum. How about if y is equal to x squared, but in the interval 0 and 2? You know the function and you know how to sketch the graph. So how about this value? You know it's easy. At x or c equal to 0, then f of c is equal to what? 0. So it's our what? So 0 and 0 is minimum point. And at x is equal to 2, so c equal to 2, f of 2 will be equal to 4, and our maximum point will be 2 and 4, right? There is no value more than 4 in this domain. This is our domain. It restricted, as I mentioned in the inverse function. So how about c? Y is equal to x squared, but there is something else. Look, our domain changed. Our domain changed. There is 0 excluded. And you know, the function will be like that. The function will be like that. Okay. Be careful. Don't forget about that. But what happened? This one is open. So max, we have a max, right? Max at c equal to, or x equal to 2. We are going to get what? And this is our domain. Do not forget. We will get f of 2 equal to 4. So 2 and 4 is max point. How about minimum? We have no minimum. Careful. Don't say I am going to put 0 here. No, there is no 0. 0 is outside of the domain because we have exclude, not include. That's why we have no maximum point. And also about d, if we have the same function, this is really very important example because give you the more exercise, give you more details. If you have something like that at 0 and 2, now there is no 0 and no 2. So what's going on? There is no maximum value and minimum value because c should be in the domain. C should be in the domain. Careful. There is no c to give us the maximum or minimum point. So that's why we say there is no maximum and no minimum. So we say no extrema value or no absolute extrema value. Okay, dear? So this is our function you can find in your lecture. This is the function that I'm going to I was talking about. And this is the last answer. And here's your graph, one by one, case by case, A, B, C, D, and you can see what's going on. Now we have something else, the theorem. Okay, and the other definition here say that in this definition, page number 3, he say that we have a local maximum. So what's the difference between local and absolute? As I told you, there's an open interval contingency, the same conditions. We have a C with the domain, and this should be happen, the number should be greater than all the other value. For example, here this value C is greater than all the other value, okay, and the X should be in the D. But we add a condition for local. As I mentioned before, we have an open interval containing C, means that we have, for example, the other example that I gave you in the before, we have what, for example, we have 0 and 2, but here if I say between -2 and 2, okay, between -2 and 2, okay, here, so we have an interval, we say between -2 and 2, or we say between 0 and 2. So because we have an interval, we can say that these maximum point are also local, okay. And really in the exam I'm not mentioning about the absolute or minimum, just I am say find the local extrema, or I am going to say just find the extreme. It's okay if you don't care about the local or mini or absolute, just find the value. So here's you can say in general, in this function really give you in this sketch, in this figure, give you many details. Here you can say what's the difference between them, because they put both definition here. Now I'm going to also do it for you. If we have something like that, we have a curve, okay. So if I'm going to change this one A to B, in general the local, the absolute max will be here, okay, and also let this one come to down here, okay, here it'll be here A, and so we have absolute maximum here, we will call as a C1, okay, and the absolute minimum here we are going to say recall as C2. At C1 is any point, and C2 we have what, absolute max, and here absolute mean. Oh yes, here's the absolute max, okay, and I'm going to write AB, okay, AM, and absolute mean. Here's absolute mean, here's absolute max, okay. Now I'm trying to what, to put the intervals here. For example, I'm going to say this is a C and D, okay, between C and D. Look, now also we have what, we have something else here, we have minimum again, here's we have max again, but this max also will change to the local. Why? Because I put the interval, okay, because I put the interval. So the absolute maximum is the maximum of the all the function. The absolute minimum is the minimum of the whole the function in R, in any domain, the whole the domain. But if I specify the domain to the interval, something like that, the maximum will change. For example, if I say CD, EF, between EF, this is a maximum, this is a minimum, for example. But this max and mean are local. This is a local max for here, and because the the absolute maximum is here, not there. But in general, I'm going to talk about EF, so I'm going to say local minimum and local maximum. That's all you can see here. And I don't care about the exam because really it's a complicated case for you. But in general, find the max and mean. That's all we need. Okay, this is our objective. So here you can see this at the same time is the absolute maximum and this is the absolute minimum because less than all the function, and this one is greater than all the function. But when you divide it to the what do you see, interval, you can recall as a local. Okay, that's all. That's the difference between the two definitions. Now we have another page of important things. As I told you, another concepts that you heard before in the high school is critical point. Okay, and before that we have a theorem. He say if this point is maximum point or minimum point, the derivative will be 0. Okay, if it's a maximum or minimum, the first derivative will be 0. But here we have a critical point. Critical point or points. The definition of the critical point is two important things. You don't forget you have a domain of the function. You see that the c belongs to d, and first derivative, if let first derivative be 0, the value of c is equal to any value, then will be our critical point. And the other definition, okay, and the other definition, take the derivative of the function if it's undefined, then c is our critical point. Now I'm going to give you the example for both sides. First of all, I'm going to page, now I'm in the page number 4, but I'm going to another page. No, later I'm going to I'm giving you more example in the later, but I'm going to give an example for undefined to understand, okay, directly without mentioning anything. If f of x, okay, equal to what? If f of x equal to 2/3, okay, so the first derivative will be what? Will be 2/3 x to power minus 1/3, which is equal to the first derivative will equal to 2/3. This will be like that. Okay, dear. So this function cannot be 0. Cannot be 0. Why? We cannot say f prime be 0 ever, never, because here is what? Here's 2. You cannot say 2 divided something should be 0. No, we cannot. So how about finding the critical? Look, if I put x to be 0 or c, I get what? In the first derivative, I say f derivative will be 2/0. Am I right? So the function, the derivative will be undefined at this point. So I say c is equal to 0 is what is our critical point. That's the case. Maybe you didn't see or you don't know how to define, or in the high school or other place. But here I'm going to talk you about this point. Is very important. If you take a first derivative and there is no 0, or there's a chance to the function be undefined at some point, so this point will be our critical point. Here our chance this function is 0 at 0, so it be undefined at x to be 0 or c to be 0. So cx and is equal to 0 is our critical point. Okay, dear. So it's very important to find the critical point. And also we have many things, many example on this one. We will give you in the next video. Before I am finishing this section 1, we have what? We have an important theorem or important part. Sometimes if you have an closed interval, how to find the absolute or extrema for the continuous function. Here's the function and here's the closed interval. So how we find the derivative? how we find, sorry, the critical point, how we find the extrema, okay? How we find the extrema, how we find the maximum and minimum. So we have a closed interval, and we need to find extrema. And you know the extrema means that you need to find the max and mean, okay? So here's the example. F of x is equal to x squared at what? -2 and 1. Yes. First of all, you should try to find the derivative, okay? Find the derivative, which is equal to c, then let be 0, okay? That will be the first derivative, be 0. So you will get what? 2x, right? 2x is equal to 0, and you will get the c, the value of c is x equal to 0. So c is equal to 0 is the 1 point. So keep this point as a result to compare with the max and mean. How we compare with what value? We will compare with the end of the function, okay? So we have a 0, and we have -2, and we have 1. So find, right, f of 0, put it in the original function, it's equal to 0 square, and it's equal to 0. Also we have two endpoints, f of -2 is equal to -2 square equal to 4. Also you have f of 1 which is equal to 1 square is equal to 1. Now list these of values that you get. First of all, you find the 0 by finding the critical or finding the derivative. The second, you find put the end points. This is the end points, end point, okay? Now you get what? You get the list of value. So the minimum is 0, the maximum is 4. So you can say we have minimum at c equal to 0, then 0 0, and max at c equal to, or you can say c on c to any number, or x, it's okay, at x equal to what? -2, then we get -2 and 4. That's all that I need from you. This is the absolute minimum and absolute maximum, okay? Here, so more example to understand these two steps. Do not forget about how to find. Here's the agenda or the strategy of finding the value. Evaluate f at all critical points. So how to find the critical points and endpoint? We find by first derivative and endpoint by finding putting endpoints. After finding, and take the largest and smallest of these values as a maximum and minimum. Another example, I'm going to give you another example. Example 4 in page 5, section 4.1. Okay, so as I mentioned, f of x is equal to x2 over 3. We solve this one at what? On which interval? On the interval -2 and 3. So here's the interval. How we find this? As I mentioned, first find the derivative, was equal to 1 over 3 2 over 3x, okay, square cubic root of x, and undefined at x is equal to 0. You know how. So here's the one of the point, and we have two endpoints, -2 and 3. So I'm going to put f of 0, f of -2, f of 3 into the function. Don't say in where, I say f, means that here. So 0, -2, and 3, 2 over the square root of 3, which means that 0 square 0, okay, which means that minus 2 square was equal to square root of cube root of 4, and this one is going to 3 is equal to cubic root of 9, and you know this is the largest, this is the smallest, so we have an absolute max in here, absolute max at 0 and 0, and also we have a it's a minimum. I have absolute minimum at what? At 3 and cubic root of 9. Okay, dear, here's the value. I don't care about this one, you don't need the detail, and here's the value. That's all that you need to find mean and max. You can see. Okay, dear, that's all about the section 1. I hope you're interested with it. Please try to study well, because there's an important things in this section. The rest one will be followed by the other video. Thank you for watching, and thank you for being for studying with me.